Okay. So it keeps cutting out. So let me see if this will work. Um, come on. Okay. So I think I kept working on this problem and then it cut out. So all I did was I graphed this line down here. So I started at -3, so I started right there, and then my slope is -3, which I can rewrite as -3/1. So because of that negative, I go down instead of up. So I go down 3, 1, 2, 3 over 1. Okay, and so that's my line right there. So with our slope, with our run, we're always going to go to the right. But if it's negative, we go down instead of up. You never want to go left though. Yeah. Okay, so now I have my two lines graphed. So now I have to shade. I don't know if you remember this, but I have to shade. So let's look at this black one, this dotted line right here. So this is y is greater than. So this is how I do it, but I'll show you another way. So I think of it's greater than. So if it's greater than, it's going to be either like to the top or to the right of the graph. And if it's less than, it's going to be down or to the left. That's where you're going to shade. So for this black one, we're going to shade, because it's greater than, we're shading up here. But if you're not sure, because sometimes it's confusing, so I have this line right here, I'm going to just test a point either above or below. It doesn't matter. I'm going to test above just because I want to use the point 0, 0. You just can't do any point on the line. So I know this 0, 0, the origin right here, is not on the line. So I'm going to try that point. So we can just test 0, 0, which this is my x, that's my y. So I just plug in these points to this equation right here, okay? So my y is now 0. It's greater than 1/3 times 0 minus 2, which then if I multiply it out, I just have 0 is greater than -2. And this is true. And because that's true, I shade this side of it, okay? The side where the point was that I chose. So those are your two options. Okay, so I've shaded this. Now I need to look at this purple line and I need to figure out if I'm going to shade above or below. It is greater than, so I am pretty sure we're going to shade this way right here. Okay, but if we want to be sure, or if that's just confusing, just look at a point that's not on the line. You can either do one above or below it. The origin is on the line, so I'm going to do that again just because zeros are nice. So I'm going to test 0, 0 again. That's my x and that's my y. So I just have 0 is greater or equal than -3 times 0 minus 3, which is just 0 is greater or equal to -3. And 0 is greater than or equal to -3. So it's true. If it wasn't true, if you got to the end and it was false, that means you would shade the other side of the line, okay? But because it's true, we're shading this side. So it's hard to see, and you won't really need to know this, but for our solution, it's where both of these shadings overlap, which is like right here, this little bit. So I'm going to shade, let me go back. So where they both overlap is right here. So this would be our solution, is this red part, which messy and hard to see, and you don't really need to know that. But what it's saying is that for these two equations, any point where this red is shaded, any point there you could plug into both these equations and it would be true, is what you're saying. So that's graphing our system. Okay. We're going to do story problems last. Let's see what we have here. delayed. Sorry. Sorry. Okay, let's go to this one, number 12. So it wants us to graph, and then it wants us to find the x and the y intercepts. So you could do this a couple of ways. Just like we did before, you can solve for y, and then you can graph it that way, and then see what the x or y intercepts are. Or you can find the x and y intercepts and then just draw a line between the two of them. So we're going to do it that way just because it's something different. So my x-intercept, okay, so if I have a line like this, my x-intercept is where it crosses the x-axis, and my y-intercept is where it crosses the y-axis. So when I have an x-intercept, my y is 0 because it's just on the y-axis. So x-intercept is when y equals 0. This would be another good one to write down. And our y-intercept is when x equals 0. With this one though, if you can't remember, you can always, like, I always like to just draw a line and say just a random line and be like, okay, my x-intercept is right here because that's where it crosses the x-axis. Okay, so when it's right here, look, my y's are 0 because I haven't moved up or down. And then the same thing with the y-intercept. This is my y-intercept, right? So my x's, I haven't moved to the left or the right. I just moved up and down. So my x has to be 0. So that's how I mean, you can always kind of just think about it that way. So for x-intercept, it's when y equals 0. So I'm just going to plug in 0 for y, and I'm going to find an x. So I have this 4x plus 0 equals 8, which is just 4x equals 8. And then I divide by 4, divide by 4. So I have x equals 2. So my y is 0 and my x is 2. So right there, that's my x-intercept. So my x-intercept is the point 2, 0. Okay, now for my y-intercept. This is when x equals 0. So I'm just going to plug in 0 for x. So I have 4 times 0 plus y equals 8. 4 plus 0 is just 0. So I just have y equals 8. So when my x is 0, my y is 8. So I have 2, 4, 6, 8 right there. Oops. 2, 4, 6, 8. Okay, so my y-intercept, 0, 8. And then I'm just drawing a line in between them. Oops, that's crooked. Well, you just might have to get the point. Something like that, okay? That's my line. So really quick, I'm just going to show you quickly. I have this 4x plus y equals 8. If I were to solve for y, I would just minus 4x, minus 4x. So I would have y equals negative 4x plus 8. So if you were to graph it that way, you would start at 8, which is what we have, right? I mean, that's what that tells us is our y-intercept. So we start at 8, and then I go down 1, 2, 3, 4 over 1. That looks right. 1, 2, 3, 4 over 1. So you should get the same thing. So you can always graph it that way and then look where the line crosses the x-axis and the y-axis. Okay. So for this one, we're given a graph and they want us to figure out a few things. They want to know what are all values of x such that f of x equals 1, what is f of 3, and what is the range. So let's start with this part A. So f of x is just kind of a fancy way for saying y. So I can always replace f of x equals y. I can always replace f of x with y. So this is just saying y equals 1. So we're gonna look at our graph and we're gonna say when y is 1, looks like I have this. Looks like I have 2 values. I'm gonna do it in pink. Looks like I've got this value right here and this value right here. So I can, when x is 1, I can say, I'm sorry, when y is 1,